we'll look at the Arduino and try to understand the components one by one. The first and main components are Atmega 328. This is the Atmega 328 microcontroller, and next one is Atmega 16U2 microcontroller. These are the two main microcontrollers which is acting as the main component in the Arduino. So Atmega 328, this you can see that this is a dual line chip microcontroller, and this is the main and brain of the Arduino board. So what it will store the sketch what we are writing in the Arduino IDE. That sketch when we are uploading to the microcontroller or Arduino board, this microcontroller will store these sketches and it will do the task to that sketch. So what is the use of Atmega 16U2 microcontroller? This is when we are connecting the USB plug through the USB plug, we are connecting to a PC or laptop, and when we are uploading the sketch, we need to convert these sketches as how the Arduino is understanding, and we need to store to Atmega 328p. So what this Atmega 16U2 will do is it will take the code from the PC through this USB plug, and it will move to Atmega 328 P microcontroller. Okay. Next one, you can see here one reset button. Reset button, when we are pressing the reset button, it will do like, it will go to the first line of the sketch and the entire microcontroller, the entire sketch or the entire task will start from the beginning. Okay. Next one is, you can see here one voltage regulator. We can give up to 20 volt to this microcontroller board, and this microcontroller need only 5 volt to work. So what it will do, when we are connecting the power supply to this power plug, external power plug, this voltage regulator will control or regulate the voltage to the 5 volt and provide to entire board. So next one is, you can see here one oscillator. So oscillator is with a 16 megahertz. Okay, you can see one L near to the 13 pin, one L, this is LED. It's an inbuilt LED. It's connected to the pin number 13. So when we are writing a code to make inbuilt LED high or low, that is like switching on the LED, switching off the LED, we have to write the code for the 13 pin number. Okay. Whenever 13 pin number is high, the LED will be on. Whenever the 13 pin is low, the LED will be off. So this LED is controlled through the pin number 13. Okay. Next one, you can see here, we can neglect the IO/REF pins and reset pins. This is not important. So we'll move to 3.3 volt pin. What is the use of 3.3 volt pin is to supply 3.3 volt, and 5 volt pin for supplying the 5 volt. And you can see two ground here and one ground here to supply the ground voltage. Then Vin means how much power supply we are giving here, that and power supply will be present in Vin. Then here the important thing is analog pin. So this A0 to A5, total 6 pins are analog input pins. We cannot provide analog output here. We can only take the input and process. Okay, so this A0 to A5 are analog input pin. So next one is, you can see here digital pins. These are 0 to 13, total 14 numbers pin. So these pins 0 to 13, we can use it as digital input output pin. So analog is an input pin and digital is input as well as output pin. Here you can see 3, 5, 6, 9, 10, 11. You can see one wave symbol, that is PWM, pulse width modulation. So what it will do is, when we need the analog output, we have to connect to this PWM pins, and these PWM pins will provide the analog output. So here A0 to A5 only for taking input, analog input. If you want to provide analog output, you have to select the pin with the PWM. Okay, so and 0 and 1, it's having dedicated use. It's like 0 is for the receiver and 1 is for the transmitter. When we are going with the Bluetooth modules and all, we will understand what is transmitter pin and what is the use of receiver pin. Okay, the next one is, here you can see two LEDs with the transmitter and receiver. So when the board is when we are uploading the code or when we are receiving some signals to the board or when we are transmitting some signal from the board, this transmitter and receiver pin will be blinking so that we will understand whether it's working properly or not. So these are the main components for this Arduino IDE. So here you can see that the type of USB. We are using type A to type B USB port. That is Arduino Uno we are taking. So Arduino Uno having inbuilt USB which is having type B and another end will be type A. We are going to connect with the PC or laptop. Okay. Then voltage regulator you can see and here one barrel connector is there. This is for connecting the external power supply. When we are connecting through the USB, we no need to supply external power supply. So when we are removing the USB connections, and if you want to keep it work in somewhere else away from the system, so we can use this external power supply. So the recommended voltage, that is 7 to 12 volt, is recommended input voltage for this Arduino, and we can give up to 20 voltage through this external power supply. So what it will do, this voltage regulator will convert the 20 volt to the required voltage for this Arduino. How it is doing is like this voltage regulator is connected with the PC board, and when the voltage is high for regulating, for example, we'll take it as a 5 volt voltage regulator. So what it will do, the power supply which we are giving through the external port, external power supply, this will provide to the voltage regulator that, for example, if it is 20 volt, we are giving 20 volt to this external power supply. The voltage regulator will take 20 voltage and convert into 5 volt. How it is converting? In the form of heat. So the extra 15 volt, if you are taking it's as a 5 volt regulator, and we are providing 20 volt, then this 5 volt voltage regulator will convert the 20 volt to 5 volt by using the heat. How it is doing is the rest of 50 volt it will convert to in the form of heat, and 5 volt will provide to the board, and 15 volt it will be in the form of heat it will remove. Okay, so how it is removing is there is no heat sink or fan connected to this board, so the heat will be supplied to the entire board and the heat will be transmitted out. So when we are this board can have like maximum 20 voltage, so that 15 volt will be transmitted as a heat. So when we are giving extra voltage like above 20 volt, the voltage regulator will convert and the more voltage will be in the form of heat, and the heat temperature will increase and board will get short. So that's why we are providing maximum of 20 volt. Now you can see here one ICSP pin. You can see here near to Atmega 328P as well as near to 16U2. Why this is like when the USB port is not working or we cannot upload the program through USB port, we have to write the program and we have to use ICSP headers. This is the ICSP header and connect this to the system and ICSP pin to which microcontroller you want. For that ICSP pin you have to connect and you have to upload the program. Next one, this I have explained. Reset button, oscillator. Oscillator is having 16 megahertz clock. And brain of the Arduino is known as Atmega 328P, and the heart of the Arduino is this oscillator. So at first second, it will provide the 16 million times the oscillation will happen. So here you can see two capacitors. So capacitor is used for providing steady power supply to avoid the fluctuations in the power supply. Okay. So next one, we are just going to see how we can provide an sketch connection to Arduino board. Here we are connecting one LED to the pin number 7, and LED is having positive as well as negative. So I'm connecting the positive to pin number 7 to provide 5 volt, and it's connected to a resistor. Then it's connected, negative side is connected to ground through a resistor. So you know, right? The LED is having two pins. One is positive, another one is negative. The longer leg is represented as positive or anode, and shorter leg is negative or cathode. So how it is working? When I am making pin number seven as high or one, in term of microcontroller or any PC or something, we are using binary, that is 0 and 1. So when it is 1, pin number 7 will be high, and pin number 7 will provide a voltage of 5 volt. Okay, when it is high or 1, the pin will provide 5 volt. So the positive is connected to 5 volt, negative is connected to ground, so the LED will glow. When I'm making pin number 7 as low, that is I'm providing 0 voltage. Okay, when it is 0 volt, the pin is low or 0. So the power supply is like same as ground. So both the pins are connected to ground means it won't work. So why we are using resistor here? To control the voltage or current. So what it will happen if you are not using the resistor, the LED, there is a chance of getting LED get uh, complaint. Okay, so this is what I explained. Pin number 7, if you are making high, the LED will be on, or pin number 7 is making low means LED will be off. This is we are going to connect the push button or switch. This will see when we are doing the program. Okay, so here you can see when 5 volt is providing, this is how the pulse width modulation will work. Okay, it's not a true analog, but what it will do is it will adjust the pulse width and it will provide. So this will be the pulse width wave, PWM wave, when we are providing the PWM pin. Okay, it's not a true analog. True analog means it should be like a sine wave or cos wave. There is no direct decreasing in the voltage, so it will slowly it have to decrease. But in case of pulse width modulation, this will be like a digital signal only, but we are using as an analog.